Okay, let's talk about Chapter 9, Mass Wasting. So, what is mass wasting? It is basically landslides and all the different types of landslides you could have, but it kind of has some more overarching uh, um, areas as well. I mean, this is kind of the main thing. You get these big flows down mountain slides where the mountainsides fail, and as you can imagine, these can be uh, pretty deadly. However, there's something else called creep, which is like really, really, really slow landslide. And then other things like avalanches and lahars that we learned in volcanism that also are kind of covered in mass wastings. But generally, it's just massive amounts of debris moving down slope due to gravity. So we'll kind of introduce you to this stuff. I'll kind of talk a little bit about classification. You can sort of classify these things, and then slope stability, which is fairly important. These are all the reasons why, or that can, sorry, these are all the variables that can affect whether or not you may have a mass wasting event. Talk about the different types of mass wasting events, and then what can we do about it? So as I mentioned, mass wasting is downhill movement of masses of bedrock, rock debris, or soil driven by the pull of gravity. So gravity here is the primary culprit that we're sort of fighting against. When I ask you that question, what's the primary cause of mass wasting events? It's not water. It's not. It's not vegetation. It's gravity, because we're fighting ultimately against gravity. Um, so two huge points here, and this is just a little bit of words on one of these slides, and I've got like 100 slides for this thing, but hopefully don't let that scare you. But this is very important, and so here you go. Landslides have been far more costly in the U.S. in terms of both lives and dollars than all other geologic and weather hazards combined. So that means volcanoes, earthquakes, tornadoes, hurricanes, floods, all of it put together can't compete with the amount of lives and dollars that landslides destroy or cost. However, that's something we're not taught. That's something we don't know. But it's amazing to me that that's the case. But it's the one sort of geologic hazard where we can do something about it, right? Like we can actually study this stuff and understand why it happens and where it happens and kind of plan against it. So it's a little bit maddening that this is the case here, that it costs so many lives and dollars, and that we can still do something about it. But anyway, so let's get on to talking about this. But I really, really, really want you guys to kind of remember this. This is really crucial. Those of you that are civil engineers, this is probably one of the more important chapters of this entire class, if not the most important chapter. Any of those that aren't civil engineers, those that are planning on being, homeowners someday, and you living here in the Ozarks, this is relevant. This is important. As taxpayers, it's important because we don't want our civil engineers going and building roads in places they shouldn't build roads if they're just going to be destroyed, and I'm going to have to pay tax dollars to fix those roads. For instance, this is just in 2017, bids open on fixing storm-damaged Arkansas roads. Cost near $8 million for 4 projects. Imagine the things we could build here in Fayetteville or Northwest Arkansas for $8 million. And it was relatively minor events. The projects are aimed at fixing locations of Highway 23 in Franklin and Madison counties, and Highway 59 in Washington and Crawford counties, and these other areas that are fairly rural. And these aren't heavily used roads. A lot of you probably haven't even driven on these roads. And it cost $8 million to fix these things. To put that in perspective, there's maybe, a million and a half taxpayers in the state of Arkansas. So essentially, everybody's going to pay, $5 to $8 to fix these roads. Hey, that's $5 to $8 I could have done something else with, I don't remember if this is the same article or not, but pig trail closed again by landslide. This is Highway 23, right here, and it's where these slide areas occur. So out here, where you have a lot of the Ozarks, kind of in this region, are kind of the tallest peaks and the highest relief in all of the Ozarks. All the Ozarks that even go up into Missouri. But you get a lot of landslide events that are kind of in here, and they can be very expensive to sort of fix things. I actually knew of some folks that were somewhere around in this area, and there was a landslide event, and they had a county road that kind of went up to their homes, and it was multiple homes of people living there, and it washed out the road, and they didn't have access to their homes anymore. And to this day, I still don't know what the solution was for those people to try to get back to their houses. But before buying this property that they had in this area, maybe if they known something about mass wasting events and landslides, maybe they would have thought twice before putting those houses where they put them. Or maybe the person that built the road would have thought twice about how they built that road or where they put that road. So important stuff. So how do we classify these things? We can classify them by their speed, material, and what the movement is like. Is it really fast? Is it really slow? The material, is it rocks? Is it snow? Is it mud? What is it? Speed, is it fast? Is it slow? Is it fast like 100 miles per hour, or is it like centimeters per year? So speed, 100 miles per hour or less than 1 centimeter per hour. Material, is it rock? Is it debris? And the movement, is it a flow? Is it a slide? Is it a fall? So what's the difference between those? Here we have slides, here we have a fall, and here we have a flow. So slides are kind of what they sound like, especially when you have layers of sedimentary rock or potentially even other types of rock. And the rocks just slide down due to gravity. Another type of slide is where it you get this kind of concave shape that gets cut out of the mountainside, and it sort of slides in this kind of conchoidal shape. If you remember conchoidal from how our quartz fractures. And then falls is basically where the rock just falls off due to erosion. It doesn't have to just be water. If we go to the field trip up in Bella Vista, there's a great rock fall that's up there, and maybe we've seen that already, or maybe we're going to go see that. If nothing else, I'll hopefully show you pictures. Then there's flow, where things kind of liquefy and they move in sort of a more liquid fashion. So, what is this? Is this a fall? I don't think it's a fall. Is it a flow? Well, it's not really liquidy. Or is it a slide? I would say this is a slide. You see all this material breaking off right here and kind of moving down this slope, yeah. So I'd say that's a slide. What about this? I think this is more of a flow. All this stuff is still together. It's not broken apart. And it's kind of fractured off back here. So it's, I don't know. Maybe it's more of a slide. Point being, again, this is one of those things. There's a little bit of gray area. We're trying to classify these different landslide events or these different mass wasting events. And sometimes they don't fit into our neat, pretty little boxes. But I guess I'd call this more of a slide. I don't know. I'm not an expert. Although I suppose you're paying me to be one. Anyway. So, what about slope stability? Let's go through these things. Angle, debris, vegetation, planes, gravity, and water. What do these have to do with everything? So the slope of the angle matters, right? How angled is your hillside? Is it angled like this? Or is it angled like this? That will affect the likelihood of you having a mass wasting event. Debris thickness. How thick is the debris? Is it really, really big and kind of all cobbled together? Or is it really fine-grained stuff that can flow very easily like a liquid? Vegetation. Vegetation, I'm just going to keep drawing here. Vegetation holds things together with its root. It is our ally. Vegetation is a good thing. You have to be careful when you live on the side of a mountain and you put a house there and you think, oh man, there's such a great view out this way. I'm just gonna, chop down all the trees, and there's no more trees here anymore. And then all of a sudden, whoosh, your house slides down. This happens a lot, or not a lot, but this happens in the Ozarks for sure. Your plane orientation. So this plane here, what's going on within it, within the geology? What's the bedding like there? Is there foliation with like metamorphic rocks? What are the fractures like? These affect whether or not your hill's going to go sliding off from underneath your feet. All planes are all planes of weakness. Sorry, yes, these are all planes of weakness. So if I've got a bunch of sedimentary rocks that are layered like that going down a slope, each contact between each bed is a plane of weakness. If I've got fractures going through here, those are also planes of weakness, especially if they are parallel or if they are perpendicular. So perpendicular, parallel. So here's an example. This is down in the Ouachita somewhere. This might probably be outside of Little Rock. I don't know. You can see this big artificial cap they kind of put on these rocks. This is some sort of cement that they just poured over there to try to keep the rocks from falling. I wouldn't park down here. If I drove up to this office and like parked down here, I wouldn't do that, or at least I wouldn't park there for very long. It's not hard to imagine, this fracture giving away and this block right here just whoosh, taking off down on your car, and all of a sudden you're calling the insurance agency and you're like, do you guys cover mass wasting events? And they'll go, what? And you'll be like, did you not take geology in college? And they'll be like, no. And I'll be like, Anyway, but you can see the parallel belting that's kind of going along here, and then sort of the perpendicular fractures that kind of go along with it. Dangerous place to park. This is our department chair, Paul Lowry, my boss basically. And again, this is the Ouachita. So you don't really see this in the Ozarks. In the Ozarks, our rocks are all nice and flat, but in the Ozarks they get a little bit tilty. And so you can see these parallel beds, but you can also see these other fractures that exist in between here. And it's not hard to imagine that these rocks, this rock right here, where do you think that came from? It might have come from up here somewhere. And these rocks right here might have come from, up here somewhere. And then the rocks that are coming down in this creek and getting carried away due to erosion, they're sliding down here into that creek, or into that stream. I won't go too much into gravity. I'll just go through it real quick, just give you a quick introduction. There's physics involved in this stuff. If you do become a civil engineer and get heavy into the effects of mass wasting or kind of slope control or just these sorts of topics, you can math this stuff. You can calculate the forces. You can look at the, where's the coefficient of friction? Oh, here we go. Resistance. Resistance basically being how slippery is your slope. So if this were ice, you'd have no resistance. And so this arrow would be much smaller. And then your force would be greater on this side, so away the thing goes. If you ever take a physics class, you'll play with block diagrams like this, or you should be looking at them. But again, it exists here in geology, and it's a real thing. So, water affects how stable your slope is. Is the soil dry? Is it damp? Is it saturated? What's the difference? Well, if you're damp, you can do cool things like this, and you can make sandcastles, which are fun, right? You notice, look how high that angle is. If you've ever gone to the beach and made sandcastles, this is kind of a neat thing you can do. If you get just the sand a little bit damp, you can build with it really easily. However, if you get it too damp, if you get it too wet, the grains just flow like they're water, and bleh, this stuff will flatten itself, maybe like this thing back here. However, if it's just a little bit damp, the little bits of water between the sand grains have great surface tension and will kind of hold the thing together. So a little bit wet is okay. Too wet is bad. And again, you can actually do math with this stuff, and you can measure your slope angles and figure out just how high of an angle you can get on your slope depending on the amount of moisture you've got in your sediment. So in this instance, a damp sandcastle is the best way to go. So dry sand, doesn't make good sandcastles. That sucks. It's got low strength, low stability. Damp sandcastle, high strength, high stability. Saturated, worthless, just oozes. And now you can say that, hey, I took geology in college and I learned how to build sandcastles. So at this instance, this initial image that I showed you guys, what probably triggered this is, one, you've got all these trees on the hillside, great. But honestly, I kind of see some houses in here, and it makes me wonder if they cleared out some of this area here. But you probably had a high rainfall. This area probably looks like somewhere near the equator in the tropics. You get a high amount of rainfall, and it's just too much mass. It's too much moisture in the sediment, and it just flows. And you can see how it just completely takes out anything in this neighborhood. This is why this stuff is so devastating. Is it just it doesn't go around your house. It just takes it out. So what can trigger these events? So triggering mechanisms. We've got earthquakes, just kind of obvious. You shake things around a little bit, and you can get mass wasting events. You add too much weight to the top of your slope, that can trigger an event. You undercut on the bottom, you cut things away like with a road or something, that can cause it to go. Heavy rainfall, which increases the mass of the slope, of the material on the slope, and so that can cause instability as well. Just sitting here to let you guys kind of look at this. This is all fairly relevant stuff. So what are the type of mass wasting events that we see? First we'll go with creep. Creep is kind of the unusual one in all of this. So it's not a single event. It's not all at once, as the name suggests. It creeps. It's very slow moving, and it happens on all slopes. You can kind of argue that creep really doesn't belong in this chapter, and it's really its own sort of thing, and maybe it's more of an erosional process, and we should talk about it when we talk about weathering and erosion. But anyway, we didn't, and we're talking about it here. So it's very slow. It's continuous downslope movement of soil. It's not really dangerous, but it can be destructive. So if you're around when the destruction happens, then yeah, I guess it can be dangerous. But here's an example. You have a very, very, very old cemetery, and you can see the slope is very gradual back here. But you can see how these tombstones have kind of been pushed over. Not so much this one, but all these other ones are kind of leaning over, and that's from that slow, slow, slow movement of soil, ever so slowly moving down this way. Another example, I think this is actually out in West Texas. I think I've been here. You can see these rocks are naturally all tilted this way, and then they get bent up here towards the top, and that's not from like plate tectonics or structural geology when we talk about that chapter. It's from the creep of this sediment. Sorry, not the sediment. The soil up here slowly moving along, and it kind of curls over the top. So how does this work? How does the soil just slowly move along like this? And this is kind of the general gist of it. Okay, so you've got some soil, and it gets wet. You get it wet with water, and it will expand. Now this is for freezing, Now, this doesn't always have to be the case, especially here in northwest Arkansas. We've got a bunch of clay that really expands when it gets water into it, and it causes a lot of problems with foundations. So it's not necessarily a freezing action with us, as it's just the soil gets wet, and the soil will expand once it gets wet, and then the clay that's in the soil will expand. But of course, also we do have the effect of freezing, and you may notice, like if you go out in your yard after it's been kind of wet, and then we get a hard freeze, you go out in your yard, and all of a sudden it's kind of crunchy almost, or there's a lot of your foot sinks down an inch or two. That's from that expansion of that soil. But as it on a slope, as it expands, this stuff, as they're showing, these rocks get held on by the top, and they move up, and then things either thaw out or dry out, and when that stuff comes back down, it comes back straight down. And so back and forth, 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 and eventually those rocks will be down here, and the soil that's up here will then be down here. And so it's just a really slow process over time. And I say really slow, it's really not all that slow. The geologic time sort of way, it's fairly fast. However, on human time scales, it's kind of slow, basically glacier slow. Here's an example where you can kind of see that these trees would have started growing straight up when they first started growing, but they moved down this slope and kind of been tilted over this way, and then they've been trying to change the direction in which they grow over time as they kind of come down the hillside. I believe this is in Fayetteville along 16 heading east out of town, and you can see all these telephone poles are a little askew, and that's from the creep that's happening on these slopes. Another location somewhere in northwest Arkansas, we've got a retaining wall that is not too far away from not being a retaining wall. And it's not just the pressure from this. I mean, it is the pressure from the stuff on this side, but over time there's more and more and more pressure, and it's pushing this stuff over. And eventually this will fail and have to be rebuilt. But there are things you can do. We will talk about it. We got things you can do for retaining walls like this to help out. So next event, earth flow. So you kind of get a slump at the top and then a scarp. So this is one of those first images I showed you. So I guess it is a flow. So you get a scarp at the top, and then the rest just kind of shifts down. So the soil is kind of liquefying down here and moving around, but the top is kind of staying in place. Example. So there's that scarp. Extreme example, much bigger event, big scarp, and all this stuff has moved down this way. Would you be standing up here if this had just happened? Another earth flow. I think this is Madison County on Highway 16. It took them a long time to fix this. I think it took them like half a year to fix this because there's not a lot of people that live in Madison County, and so there's not a whole lot of budget. So they needed to basically wait till some more tax revenue came in until they had the money to fix this. And it probably costs like 20 grand to fix this, maybe 40 grand, something like that. Which is quite a bit of money. I will attach the PowerPoint in Canvas. If you want to come click on these links, you can click on these links, and it just kind of shows these some of these events happening. So they can be kind of quite devastating. So then we have mud flows and debris flows, and it's kind of what it sounds like. Instead of just like a earth flow where it's just the earth kind of coming down the side but staying relatively intact, this is more water oriented and is much more like a flood with stuff in it. It'll usually be channelized, which means it's staying close to a riverbed, and it's just happens really fast and can be really deadly and can go for very long distances. These really are a lot of the, this kills a lot of people, to be frank. It happens a lot with volcanoes, where you get all of a sudden get a whole lot of the snow and ice on top of your volcanic peak. It's melting, and all that water rushes down the side of the volcano, gets into the lower lying areas. So that's kind of how it's channelized. So these little places that used to be little creeks are now all of a sudden 20 feet deep mud flows and debris flows. This will also happen with wildfires. How does it happen with wildfires? Well, the wildfires are killing all the vegetation. You get a heavy rain on a hillside or on a mountainside where you've killed all the vegetation, and now all that mud, all that soil that was in place can now get carried away. Case in point, volcano. So here you have one. So you have the eruption up here, and then you can see this mud flow, which we call lahar, moving down the side of this volcano. When they do hit civilized areas, they can be fantastically destructive. I mean, this was a bridge at some point, and it got carried away, and it's now buried. And how do you get that? You don't. This is done for. You don't pull the bridge out of this sediment anymore. Same thing with houses. I mean, once this stuff settles, you're going to dig out your house. How? These are roofs. I imagine there are buildings under here. I'm kind of surprised the buildings are still there, to be honest. So an avalanche is kind of like a mud flow or debris flow, but it's air. It's not dominated by water. So with, creeps are slow. Earth flows is pretty much just the land shifting and the soil. And then this is where you add water. And now you've got air. So if anybody's a skier or snowboarder, you know a lot about these. And they can be fairly deadly, and they happen, in the mountains, and they're avalanches. So eventually this will get going, break up, and will turn into an avalanche. We also have rock slides, which is I kind of basically showed you earlier, and you've got bedding that's parallel to the slope, and you have whole chunks of rocks that can slide down the mountain. And once it kind of breaks up, it'll turn into an avalanche. So, an avalanche, generally we think of snow and we think of avalanches, but it's not restricted to snow. It can also be rocks. So, for instance, we've got these bedding planes here that are parallel. You get this stuff a little bit wet, and you get it to fail, and boom, down it slides into the valley. This is actually a good example. So you can see this stuff up here ends up going down here, and we've got a river down here, right? Well, when this happens, you can dam up the rivers and create, if this is upstream up here, you can create flooding events backstream when you have these rock slides or avalanches. There's a picture. And we also have rock falls, which is kind of what they sound like. The rock just falls down the mountainside. There's a cliff, and it just falls. Famous face that was on this this mountainside. I forget what it was called. But over time, it actually fell, and no more face. This usually happens. Well, this does happen because you'll get erosion that undercuts it. And it may be because of differential weathering. You've got a sandstone block up here, and then you've got shale that's down here. And shale will weather more easily than sandstone will, but once you weather that shale back far enough, it allows these rocks to fracture off and just break off. And you see this a lot in areas that don't have a whole lot of vegetation. Actually, you see it some in areas that do have vegetation. If you just drive up 71 into Bella Vista, you will see these big blocks sitting on the side of the road, and you can tell they used to be connected up here to where the sandstone was. Or maybe it was limestone. And same thing with water erosion. We call that material that falls down talus. Don't worry too much about that. So here's what I'm talking about. You've got some big block up here that's either limestone or sandstone. This is probably sandstone. And then you've got this shale unit that's down here. And the shale slowly weathers back more. And then as it gets underneath that sandstone, the rocks, the big blocks of sandstone come tumbling down. So in case we don't go on the field trip, this is up in Bella Vista, where you've got you can see all this shale right here, and you can see this limestone up here, and you can see that this block right here connected back up into there, and it broke and fell down. And once this kind of material weathers out as well, you know, this block will eventually fall down. So how do we prevent this stuff? This is a real thing. You work in construction, you're a civil engineer, you're a construction worker. This is something you come into contact with quite frequently. If you just look around and pay attention, you can see the mitigation efforts, the safety measures that are put into place when we see road construction around here, a road widening or what have you. So things you have to watch out for is the removal of vegetation. I know there's a lot of work that happened on the road that goes out to XNA, the airport, and there were these big steep hillsides, and I watched them. I watched them remove all these old trees, and I'm just like, you guys, that's too close to the road, and that slope is too high. That is going to fail at some point. And then I think within a couple of weeks, they put a whole, they did something for it. They mitigated it. So you have to be careful about over steepening a slope. That's, you know, kind of obvious. You don't want to make your slope too steep. And then being careful with cutting and filling areas, as well as adding weight. And water. So what am I talking about? So here is our natural slope. It is nice and happy and stable. And then man comes in, evil people, and their construction. Ooh. You might put a road in at the base of it and kind of do a road cut. Well, now all of a sudden you don't have nearly, you know, this used to connect down here, and the material that was once there was keeping this stuff from moving that way, and now it might potentially move that way. Or you've got this just really steep angle. Anything that's kind of up in this area can move down now. You remove vegetation on this hillside, on this part of the hillside, and it can start moving down hillside. If you're up here at your house, you're adding water. I mean, this is just kind of the perfect, you know, event for potentially having a really bad mass wasting event in this area. You get the point. So what should we do? Should we stop construction? That's unrealistic. I mean, we need to construct things. We need to put in roads. Like, you know, it's what we do. Do we just avoid slopes altogether? Well, flat ground can be kind of rare or already occupied. I mean, just look around here up in Bella Vista. You know, there's a lot of development that happens up on the hillsides, and then there's slopes in between. So how do we lessen the likelihood of failure and also mitigate the danger? How do we stay safe? So first off is just site selection, being careful about where you put things, really paying attention to the geology in the area. You know, if you've got rocks that are, if you're trying to go around a mountain, don't go around the mountainside where the rocks are tilting towards you. You know, not a that's not a good idea. So, you know, mountainside, and if the sedimentary rocks are kind of tilting this way, you know, you don't want to put your road over here because these things are going to slide this way. You want to put your road over here. You can do something that's called stitching, which is kind of neat and kind of what it sounds like. You basically bolt the hillside into place. So you drill down into these areas of weakness, and you just basically put a big old washer on there and a big old bolt, and it caps it into place. And you can see that they've done that here, and they put some cement over it, and it keeps this stuff from coming down here and hitting the car. Much closer, same sort of thing. You're bolting the surface of that rock on to where it is, keeping it from moving. These fences are another way to sort of mitigate danger, to keep boulders from just, you know, tumbling down and getting off into the roadside. They'll at least kind of keep stuff there, hopefully. So you can also just do full-blown removal. So taking my little hillside analogy, instead of putting your road on this side, just get rid of the mountainside. And sometimes this isn't economical, but sometimes it is, and sometimes it's a good option. You can build retaining walls, but you also want to build retaining walls smartly. And there was a really cool thing that happened in my class. I had a guy who worked in construction. It was like a construction team leader, and he was kind of working with an engineer. And he came into class one night and was like, "Hey man, I'm actually working for the Tysons. They want me to put in this kind of crazy sidewalk." And the lady said, "Money's, you know, no option." And I promise this actually happened. And she was requesting, this is like the granddaughter of Tyson, maybe the daughter. Anyway, she wanted something that she said, quote, would last 200 years or more. And money is no option. So I said, well, okay. You know, I was like, first off, I'm not an engineer, so I don't know for sure, but let's talk about all the things we could potentially do. And you know, this stuff was kind of the first sort of thing, is like, it's got a drain, and he had issues with the drainage where he needed to get rid of this material, the water that would drain through the retaining wall here. He needed this to go somewhere too, so we kind of talked about having a secondary drain along here, but you also kind of have to watch out for sediment that come out of these drains. So if you have sediment coming out of these drains, maybe you put a little bit of some filters along some of them, or you need to make this drain to where you can open it up and get some of that sediment out there occasionally. We talked about putting trees along these slopes to kind of hold the slopes in place so they don't move down so much. And we also talked about putting, I'll go over here and use this one, putting something into the ground here that goes way back, and then kind of sort of like that stitching I talked about, but just sort of in a reverse manner. You're sort of holding the wall there by anchoring it back here. But if you do none of these, your retaining wall is going to end up getting pushed over. So examples, this retaining wall here, you can see it's kind of broken up. The water can get through it. These retaining walls, not so much. And you can see how this is definitely tipping over. You can also use fencing like we kind of saw before. You can also do something about drainage. This is actually something I occasionally have to deal with in my day job. Assuming I'm not watching it 5 years, assuming you're not watching this 5 years from now and I have a different day job. But landfills. So landfills over time, you will get filled, and what will happen is you will cap the landfill. You put material over it to kind of cover all the garbage, and you make it really thick, and so you know it just doesn't get eroded away and become a huge mess. But also, you don't want your cap or the top of the landfill to just disappear on you. So you put in these big drainage ditches to help deal with the erosion. And again, we actually see this on the side of the road up in Bella Vista, and you can make the determination of whether they're doing a good job or not, and if it was well designed. And there's kind of some debate to that. We can also do terracing, which is definitely something we'll see on the field trip. So this is actually the place we go to, and you can see they terraced. The highway department did, but they did it right on the contacts of the geology, which is kind of nifty that they did that, and convenient for them as well. And then kind of the last thing is something called quick veg. This is something when I used to do remediation up in Alaska, if we kind of had to come in and remove a whole bunch of contaminated soil, we might bring in more soil, then all of a sudden you're just sitting there with a bunch of mud that can just run away really easily. What do? Well, there's this stuff called quick veg, and it's kind of a slurry, and you just hose down the dirt, and it's seed mixture and a whole bunch of other stuff. Basically gets your grass growing really quickly. And it's called a hydroseed. But you have to be careful with this stuff that you don't use seeds or you don't use plants that are invasive. So not really anymore, because hopefully people are smart enough about it. But this is kudlo, I believe, and it's a Chinese vine that was used for this, and it's very invasive. And if you drive around Arkansas, it's not hard to spot this stuff, and it can absolutely just take things over time. If you drive down Weddington from Fayetteville, like you're going to Salem Springs, so you take that road all the way to Salem Springs, you'll run into pockets of this stuff where you can see a ton of it. So that's like Lake Weddington area is kind of where you'll see it. But it can really take over and devastate a lot of things. Another place is if you go to Artist Point, if you drive down Highway 71. Like you're going all the way down to Fort Smith. There's a place called Artist Point. It's got a great view, and there's this really steep hillside right next to the little Artist Point there where the little shop is, where the little business is, and this stuff is just covering the hillside. Well, it's doing a good job of keeping it of eroding away, and it's also keeping out all the trees so you can have a nice view, but it's slowly making its way into all the trees and killing all the trees. Grading. Yeah. You can also load the tow. So this is around here somewhere. Actually, this is 49, I think. Right south of Weddington. If you look up on the hillside, you can see this stuff, and it's called loading the tow. And so what you've done is you've cut in a road down here at the bottom of this hillside, and you're running the risk of this hillside now squirting out, essentially, because you've taken off the bottom. Well, to help deal with that, you can put a whole bunch of mass on the tow, like loading the tow. Ultimately, with a lot of this stuff, there's kind of a good lesson here. Is this really going to hold back this mountainside? Yeah, probably, especially if you don't remove all the trees. If you remove all the trees, yeah, maybe you may have some other issues. And there's, I talk about, civil engineers need to be better and they need to make better decisions. But a lot of the time, it comes down to basically safety versus money. What's practical, and what kind of resources do we have to deal with this? And a lot of times, it's kind of hard to make those decisions. How much safety, how much risk do you want to? You can also call this risk. How much money do you want to spend to kind of mitigate the risk or compromise safety? And maybe you put the road in through one area, and you know that it's probably going to wash away at some point in the future. But you had to put a roadway through here, and you know what? It's better where you put it versus on the other side of the mountain. So the hope is that you kind of learn this stuff, and you can make that decision of the better place to put it. And hopefully, some of this stuff has actual applications to you guys. Any of you hunters out there that have hunting property in the mountains, you have to deal with putting in roads and, where do I put in this road? Where's the good spot to put it? And you can kind of look at this stuff and try to make better decisions based on that. Or if you guys, some of you do become civil engineers, this is definitely relevant. But anyway, that's all. Hopefully you learned something. And yeah. Have a good one.